Now let's solve three quadratic equations from the miscellaneous exercise. All these questions can be solved using the quadratic formula, but before applying it, always calculate the discriminant because it tells us the nature of the roots. Let's begin with question 6. The equation is 3x square minus 4x plus 20 by 3 equals 0. Here a equals 3, b equals minus 4 and c equals 20 by 3. The discriminant is b square minus 4ac. This becomes 16 minus 4 multiplied by 3 multiplied by 20 by 3. The 3's cancel and we get 16 minus 80, which is minus 64. Since the discriminant is negative, the roots will be complex. Now apply the quadratic formula. X equals minus b plus or minus root of minus 64 divided by 2a. This becomes 4 plus or minus 8i divided by 6. Simplifying further gives 2 plus or minus 4i divided by 3, all divided by 3. Finally, the roots are 2 by 3 plus 4 by 3i and 2 by 3 minus 4 by 3i. Now let's solve question 7. The equation is x square minus 2x plus 3 by 2 equals 0. Here a equals 1, b equals minus 2 and c equals 3 by 2. The discriminant becomes 4 minus 6, which is minus 2. Once again, the roots are complex. Applying the quadratic formula gives x equals 2 plus or minus root of minus 2 divided by 2. Since root of minus 2 is root 2 multiplied by I, we get 2 plus or minus root 2i divided by 2. Finally, the roots are 1 plus root 2 by 2i and 1 minus root 2 by 2i. Notice how the real part remains the same while only the sign of the imaginary part changes. This always happens because the roots occur as conjugate pairs whenever the coefficients are real. Now let's solve question 8. The equation is 27x square minus 10x plus 1 equals 0. Here a equals 27, b equals minus 10, and c equals 1. The discriminant becomes 100 minus 108, which is minus 8. Again, we get complex roots. Now substitute into the quadratic formula. X equals 10 plus or minus root of minus 8 divided by 54. Root of minus 8 can be written as 2 root 2i. Substituting this gives 10 plus or minus 2 root 2i divided by 54. Finally, divide the numerator and denominator by 2. The roots become 5 plus or minus root 2i divided by 27. So the two solutions are 5 by 27 plus root 2 by 27i and 5 by 27 minus root 2 by 27i. From these three examples, one important pattern becomes very clear. Whenever the discriminant is negative, the roots are never real. They always appear as a pair of complex conjugates. The real parts remain identical, while the imaginary parts differ only in sign. Once you remember this idea, solving quadratic equations with complex roots becomes much faster and much more intuitive.